Let's see what the gradient mapping actually means, and the basic concept behind it. Given a black and white input image and a colored gradient, all black and white values are mapped into the equivalent color values of the given gradient. So it applies a gradient of color to your image depending on the tones in the image. Where the image is darker, the colors at the left of the gradient are applied, and where the image is lighter, the colors at the right of the gradient are applied. Let's take a look as to what this actually means in this example, using the gradient map adjustment layer in Photoshop. When we apply our colored gradient to a black and white image of a flame, we get the result shown below. The gradient functions produce procedurally generated gradients made from texture coordinate expressions. They save memory over having to create a texture-based gradient. Now let's understand what are the gradient functions in Unreal. First is radial gradient exponential. The radial gradient exponential function uses UV channel 0 to produce a radial gradient, giving the user the ability to adjust the radius and offset the center point. There are two inputs, UVs, which is a vector 2, which allows the ability to control where the gradient resides and how much it covers the 0 to 1 space. Center position, which is a vector 2. This is a 0 to 1 based offset for the position of the gradient center. Here only R and G channel works, out of RGB channel. B channel have no effect here. Radius, which is a scalar, this controls the size of the radial gradient from its center. The default of 0.5 puts the edges of the gradient at about the edge of the texture space. Density, which is also scalar. Density adjusts the hardness of the resultant gradient generated by the function. The higher the number means the sharper the gradient. Invert density, which is a Boolean. Invert density inverts white into black and black into white for the gradient. So here the gradient material instance has been created, and to check the various effects. Next is diamond gradient. The diamond gradient function uses UV channel 0 to produce a radial gradient, giving the user the ability to adjust the falloff rate of the gradient. Let's check the inputs. Falloff, which is a scalar. Falloff boosts gradient contrast by controlling how quickly the gradient shifts from white to black. Next is linear gradient. The linear gradient function uses UV channel 0 to generate a linear gradient in either the U or V direction, depending on which output is used. Let's check the inputs. First is U gradient. This outputs a linear gradient in the U direction. Next is V gradient. This outputs a linear gradient in the V direction. Okay, here we have added a scalar and multiply node. And then connected to the base color. Now we will change the blend mode to masked from opaque. And then connect multiply output to the opacity mask. After adjusting the single vector amount, the black portion is visible, and the white portion is masked out. On changing the scalar amount, the amount of black portion changes. But no more gradient is visible. So in spite if gradient applied, it's masked. Now select the gradient main node and go down and make Dither enabled. On enabling the Dither you can see the gradient type masked effect. But it's still not smooth. To have it smooth, change the blend mode to translucent, from masked. And connect the output node of the multiply node to opacity from the opacity mask. Here we are. Now the gradient mode is quite smooth. Let's add some colors to the gradient and make it more visible. Here are some other examples, where linear gradient is used with add node. Where the new color is gradient with the white. With lerp note two different colors are gradient along with the white color. And with subtracting note, the new effect is evident. Hope from this video, you will start to move into building in more advanced mechanics, in an easy-to-follow step-by-step approach, which will allow you to play around and build your own content, to eventually build your own game. Thanks a lot, see you in the next video.